Okay, we've got a question here on circles. We've got a circle's centre. We've been given the centre, -2, 6, and passes through 10, 11. And we've been asked, first of all, to show that the circle also passes through 10, 1. Okay, I've written here in green the equation of a circle, the general equation of a circle. What don't we know? Well, what we don't know is the radius. But the good thing is we do know that it does pass through this point here. Okay, well, let's start by putting in the centre values that we have and working on from there. Okay, so we've got x minus... Now, the negative sign is in the formula, and because we've got a negative x, this is plus 2 squared plus y minus 6 squared is equal to r squared. And because we know a point, we know that there is a value of x, which is 10, and if I put in the value of y, which is 11, which is the point on the circle, this should satisfy the circle's equation and give us the value of r. And we get 10 plus 2 is 12 squared, plus 11 minus 6 is 5 squared, and this is equal to r squared. And therefore I can say this is 144 plus 25. You should actually know this is one of the standard right-angle triangles, which gives a convenient answer, is equal to r squared. Let's go on in case you don't recognise it. This is 169 is equal to r squared, and therefore r is equal to 13. And that's the first of our useful results. Yes, I know plus or minus 13, but because this is a positive diagram, we can reject the negative solution of the square root of r squared. Okay, now that we've got r squared, we can now test the other point they suggest, which is 10, 1. So I now sub x is equal to 10 again, y is equal to 1. And I get, again, it's going to be 12 squared plus y minus 6. 1 minus 6 is negative 5 squared. And that is equal to 13 squared. And as these are the same numbers, when we square a negative number, we'll get a positive answer. So yes, I can say, therefore, the left-hand side equals the right-hand side, and therefore 10, 1 is on the circle. So part B, we've got a tangent to the point 10, 11, which is the point they gave us, and another tangent to the point 10, 1, and they meet the y-axis at points P and Q. Okay, well, let's put that onto the diagram. So I've drawn those two tangents and formed the points P and Q. Now, this diagram is no way to scale, so, you know, it's there for illustrative purposes only. But it does show roughly what's going on. And we need to find the distance of PQ, which means, of course, if we can find the y-coordinate of P and the y-coordinate of Q, we just subtract them. That will give us the length of PQ. It might help to pop on these two radii here. Now, they will meet the tangents at right angles, one of those circle theorems. I notice also, because of symmetry, the two tangents meet at the line y equals 6. That might also prove useful soon. That all stems from the fact that we've got the same x-coordinate for the two meeting points of the tangent. The diagram was quite useful in confirming that symmetry. So what I'm now going to do is find the gradient of this line here. Once I've found the gradient, the normal gradient of the line through P will be the negative reciprocal of that. So let's get that underway. So the gradient is rise over run. So the rise from 6 to 11 is 5. And the run from -2 up to 10 is 12. Let's call that point P dashed. I know what I'm talking about. So this is the gradient of O to P dashed. So therefore, the gradient of the line through P is negative 12 over 5. And because we know a coordinate point on that line that goes through P, I can use those coordinates to find the equation of that line. So therefore, negative 12 over 5, which is the gradient, is equal to y minus the y coordinate, which is 11, divided by x minus the x coordinate, which is 10. So we cross multiply and get negative 12 multiplied by x minus 10 is equal to 5 y minus 11. Multiplying out negative 12x plus 120 is equal to 5y minus 55. Therefore, putting y on the left and everything else on the right, 5y is equal to negative 12x. 120 plus 55 is 175. We need the y coordinate of P. What's special about P? Well, what's special about P is it lies on the axis, which means that x is naught. So I can say, therefore, at P, x equals naught. Therefore, putting that into our equation here, I get 5y is equal to 175. And y is equal to 175 divided by 5. 5 into 17 goes 3 with 2 remainder, and 5 into 25 goes 5. So the y coordinate of P, y equals 35. Now, because of the symmetry of our tangents that we found from one of the circle theorems, because we've got a kite forming here, the distance between 35 and 6 is 29, which means that the distance between y equals 6 and the point Q must also be 29. So I can say PQ must equal 2 times 29, which is equal to 58. And that's proved as required. And there's your answer.